In this video, I introduce matching networks for one-shot learning. Matching networks can predict a label of unlabeled data in one-shot learning without any fine-tuning network. Given a labeled dataset S, we train a parametric model on this labeled dataset to predict the label for each input data xi. And then we use a non-parametric model to predict the label for input data x with hat that is never seen in the training data set. To do so, we use the trained parametric model to generate a feature G in feature space, and we generate a feature F for the input data S with hat. And then in feature space, we calculate the attention A. And then we use A to calculate the probability of label Y with hat given X with hat and S by computing sum of weighted values YI. If XI is far away from X with hat, the attention A will be 0. For example, given B, XI far away from X with hat according to some distance metric, this equation is equivalent to K minus B nearest neighbors. Attention A is a softmax function over the cosine distance C, where C is a similarity score between feature F and feature G. If input is an image, a convolutional neural network is used to extract features from the input image. If input is a word, embedding matrix is used to encode the word into word representations. Here we use F prime, G prime as the feature for the input. We use bidirectional LSTM as the parametric model. First, we use G prime as the input. We train the bidirectional LSTM on the training dataset to generate this feature G. And then we use F prime as the input to the trained bidirectional LSTM to embed unlabeled X with a hat. And then from this output F and G, we calculate the attention A. For example, if we input the images, we train a bidirectional LSTM on this label dataset to generate feature G. And then we use the trained bidirectional LSTM to convert this input to a embedded feature F. And then we use the features F, G to calculate the attention. And then we use the attention and this labels together to calculate the label of the new data that is never seen in the training data set. We use the log probability of label Y given X and S to define objective function. And then we use objective function to train the model. The trained model can be used to predict the label of new input data that is never seen in the training data set. For more details, please check with this reference. Thank you. Bye.